Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video that you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I am going to present molecular weight and the density of epoxy resins. Molecular weight is sum of the atomic weights of the atoms in a molecule. Atomic weight is the related mass of an atom of any elements based on the scale in which a specific carbon atom, carbon 12, is assigned a mass value of 12. For example, an ACl has a molecular weight of 58.5 daltons. Na equals to 22.9897 dalton, and Cl is 35.45. The sum of these two amounts to 58.5 daltons. Molecular mass is the molecular weight in grams. Mass corresponds to 1 mole. In a nutshell, it says how many grams are in 1 mole of the substance. The mole is the standard method in chemistry for communicating how much of a substance is present. For example, an ACl has a molar mass of 58.5 grams, which means that 6.02 multiplied by 10 to power 23 molecules of NaCl weigh 58.5 grams, or 1 mole of NaCl weighed 58.5 grams.
Let's talk about the importance and relevance of molecular weight in the polymer domain. As you can see in this slide, the molecular weight, when molecular weight is increasing, technically the mechanical strength is also increasing. Toughness is increasing, stress crack resistance will be increased, and melt flow decreases. And also the melting point is increasing, and glass transition will be increased, and thermal properties as well. Moreover, the chemical resistance is also improved when we have a higher molecular weight polymer. In polymers, molecular weight estimates the average length of the polymer chain, similar to degree of polymerization, which can be presented by dP. And the molecular weight would be the molecular weight of a monomer multiplied by a degree of polymerization in that polymer. For example, if we have a polystyrene, molecular weight is 104 Dalton, and its degree of polymerization is 1000. So it means that a polymer of polystyrene would have 1000 monomers with the weight of 104. Therefore, the molecular weight is about 10 hundred thousandths. For another molecule, for example, for polyethylene, it would be 50,000 because its molecular weight, the unit molecular weight of the monomer is smaller. Molecular weight can be measured based on different methods. Osmometry is one of the methods which is often used. The light scattering, solution viscosity, and more often SEC or size exclusion chromatography will be used to report this value. Molecular weight is characterized by weight average molecular weight and number average molecular weight, which represent by MW and MN. And polydispersity is the ratio of molecular weight and divided by average molecular weight.
As the number of repeating units in the epoxy resin formula is increasing, the molecular weight of the resin is also increasing. For this presented generic chemical structure, if N is equal to 1, the molecular weight is 624. For N equals to 2, which means we have 2 repeating units, the molecular weight is 908, and so on. For each time N increased by 1, the molecular weight increases by 284. A low molecular epoxy with a mean molecular weight of 380 is liquid at room temperature, while an epoxy resin with a mean molecular weight of 1000 is solid at room temperature. The molecular weight determines what the epoxy resin can be used for. It also can be used to measure the EEW of the resin and therefore for calculating the amount of the required hardener for the curing. EEW will be explained in a separate video. For example, epoxy resins with two epoxy groups in each molecule, like the one shown here, with an average molecular weight of 382, would have an EEW of 191, which means 382 divided by 2. So if you know the number of epoxy rings per molecule and the molecular weight, you simply can calculate the EEW and estimate the amount of the required hardener or the curing agents. Epoxy resin with a mean molecular weight of over 700 is called high molecular, and epoxy resin with a mean molecular weight of under 700 is considered as low molecular. The low molecular can be handled without solvent additives, which evaporates and are therefore used for casting, teak coatings, gap fillings, glues, etc. And the high molecular epoxy resins must, as a rule, be dissolved in organic solvent to be manageable, which limits usage to paints and lacquers. Thanks for your attention. I hope you found this video interesting. Please share your thoughts, comments, or questions, and I will come back to you soon. Have a great day.